Welcome to this section wherein we're trying to understand what is data. And trust me, guys, most of the people don't, understand what is data, and then they face a lot of difficulties. If you do not understand the type of data, then there is a problem because that's a basis of applying any kind of analytics. And if you know the correct classification of the data, if you know the correct type of the data, then it's pretty easy for you to apply analytics. Now we'll understand the data bit by bit, and we'll talk about this, as a whole, right? So first thing first, the definition of data. Anything nowadays is which is in recorded is called data. It could be an image, it could be a video, it could be a URL, or it could be any text, or it could be anything which is recorded. Anything which is stored is called data. And nowadays we are living in the era where everything is digital, right? Everything is being recorded somehow or other. Your calls, your SMSs, your WhatsApp is being recorded somehow or other. So anything which is recorded is called data. Nowadays term, you will say anything which is digitally recorded is called data. So data is in context of computing refers to distinct pieces of digital information. Data is usually formatted in a specific way and can exist in the variety of forms such as numbers, text, URLs, or videos, or any kind other kind, right? So data is nothing but anything which is digitally recorded and being saved, and from that you can take out some inferences. So if you have data, you can do analysis, and if you do not have data, then you have to collect the data and then do the analysis. So if somebody is asking you to do the analysis without the data, probably that's not the right way of doing any kind of stuff. So you can straight away say no to it. Now, what is data and what is statistical data, right? There's a very minute difference between these two things, right? So the collection of data that are relevant to the problem being studied is commonly the most difficult, and it's expensive in terms of resources because it takes a lot of computational power, it takes a lot of efforts, and it's most time consuming part of the entire research project, which means that you have to really put in a lot of efforts to find out the relevant data, because non-relevant data is always available. It's all about the relevancy, right? So what is statistical data? Anything which is being used, which can be expressed in numbers to form some kind of information, is called statistical data, right? So statistical data is essentially, so for example, somebody has written some text, right? That might be a simple data. However, if you find out how many times hope, how many times war, how many times peace, or how many times education word is coming into that data, that is called statistical data. Now, even this statistical data is of two types, right? So one is called primary data, and the second one is called secondary data. So primary data is nothing but which are collected specifically for the analytics desired, and the secondary data is already been compiled and available for statistical analysis, which means that primary data may lead to the secondary data at times, right? So this is the two types of statistical data. Now, when you deal with statistical data, there are two terms which are very important. One is called variable, and the second is called constant. And I'm giving you the individual definitions right now, but you can understand that over a period of time, you will find that these definitions are very much helpful, and I'll be connecting all the dots for you. A variable is an item of interest that can take on many different numerical values. For example, if I have the x, the value of x could be 100, 200, 150, 150.5. X could be used as a variable where it can have multiple numerical values. However, the constant has a fixed numerical values and it will remain as it is. So I can also define like x is equals to a constant number. I can just fix the value of x as well, right, throughout the project. For example, pi has a fixed value in the whole analysis, right? So you may not want to change pi value. You can't basically. So there are certain numbers which has got fixed numerical value and they are called as constant. Now this is where I'll be laying down the foundation for the data analysis, and I want your full attention to understand this. Statistical data, the data which I'm going to use it for analysis or for information seeking, is of two types, right? Either I got it by counting or by measuring some kind of items, right? And if you just pick up any data, statistical data specifically, they can be divided into two parts. One is called qualitative data and the second one is called quantitative data. The qualitative data is, it's all about the qualities, information that cannot be measured on the number scale. For example, I would say my hair are, they have darker color than your hair, right? So you cannot express that into a numbers. Like nowadays we have numbers for the scales, like numbers for the colors also, but just think, like I'm more honest than you, right? You cannot express that into a number basically. So there are certain numbers, some data which cannot be expressed on the numerical scale. Quantitative data is just opposite to that. Any observation that can be measured on the numerical scale is called quantitative data. So I have 3 cell phones, I have 4 cars, I have 5 email addresses, I received 28 emails. So just think, I have got 28 emails. So I can express my emails with numbers. However, if I say that the email which I've received from Anthony is better than what I've got from Lex, then this is the qualitative data, because you cannot express that in numbers. You can understand that they have a degree of superiority. Anthony's email is much more better than the Lex's email, but I can simply say that you cannot define that in numbers, and that's where the qualitative data and quantitative data are different. So if you talk about the qualitative data, they are generally described by words or letters. They are not as widely used as quantitative data because most of the techniques, numerical techniques, do not apply to it. What is the average hair color or average blood type? It doesn't make any sense, right? So what is the average of honest and black hair? It doesn't make any sense. So you should not be like talking about the qualitative data in such a way. Qualitative data can be like separated into two groups further, right? One is called dichotomic, and then the second one is called polynomic. Now, there are certain kind of data where the output or the form of the words which has got only two options, right? One is called, like, say yes and no. For example, your loan is approved or not approved, or the person was male or female, or whether you reach office on time or not, or you can simply say whether somebody is dead or not, somebody has got a cancer or not, somebody is infected with a certain disease or not. Then it is called dichotomous data. Di means two, that it will just take the form of a word which has got only two possibilities, not more than two. The second kind of data is called polynomic data, and this polynomic data can have more than two categories or more than two possible options. For example, what is your education? It could be primary school, it could be secondary school or university. What degree you hold? You may be holding a BTech degree or BE degree or MBA or BBA or BCA or MCA or MS. Right? There could be more than two options or more than two possible values for one kind of data. This is called as polynomic data, right? Now, quantitative data is generally having again two types. It's always a number, right? It is represented in a number. It is either counted or being measured. So if you're counting the numbers, then it is called as discrete data, which is one of the type of quantitative data. And if you are measuring the number, then it is a continuous data. So if I'll summarize, quantitative data has got two types. One is called discrete and the second one is called continuous. And discrete data occurs when you count something, right? How many people have actually graduated, like the number you are counting, like there are 10 people who have graduated this year from this university. Or if you are measuring something, for example, how much distance you have traveled, what is the weight of a person, how much is your salary, how much sales revenue has been achieved by one organization, and then you have got multiple other things. So anything which is for which I have a scale available, I'll be calling it as continuous data. Anything which is a result of counting is called discrete data. And that's exactly where the machine learning starts hitting. So if you don't understand the qualitative data and quantitative data, it's pretty difficult for you to apply machine learning algorithms. So just make sure that you understand this concept, and in case you have any question, feel free to comment and then help me with your question, and I'll try to answer those questions. So if you just combine all those variables together, so you remember we talked about two types. One is called constant and another one is called variables. Variables can be of two types. One is qualitative and the second one is quantitative. Qualitative is often being expressed in text format or in the format where the numerical applications cannot be applied. However, quantitative data is something where you can apply numerical methods like taking out the average, taking out the variance or standard deviation, or taking out the mean of the data. Qualitative data is being divided into two parts. Again, one is called dichotomic and the second one is polynomic. Dichotomic data where you can have two possible values, and polynomic data where you can have more than two possible options for something. Quantitative data has got again two types. One is discrete, which has got counting in the bucket. Continuous data is the output of measuring something. It could be a weight of a student, how much tax you have paid, how much salary you've got, how much sales has been made by one organization, and so on and so forth. So I hope it is clear to everyone, right? Now, if you divide this data further, you will have four types of data. One is called numerical scale of measurement, which is the nominal value. Nominal value represents discrete units that are used to label variables that have got no quantitative values. Like categories are in no logical order and have got no particular relationship. These categories are said to be mutually exclusive, such as individual, object, or measurement that can be included in only one of them. Which means, if I'll summarize this, or if I get into the depth of definition, which means that, say I want to buy a TV, so I have an option of LG, Samsung, and then I have got an option of Onida for that matter, right? These are the three popular brands in India. So if I go for nominal data, I do not have any preference, right? There is no logical order. There is, you cannot simply, you've got at least, you will get at least one and only one. So which means that if you bought LG TV, you might not be buying Samsung. If you bought Samsung, you might not be buying Onida, and so on and so forth. So they are called mutually exclusive, which means that only one individual will appear into the measurement, or there will be one and only one, and they have got no particular order. Like for example, you cannot say they are all like major brands. You cannot say it's Samsung has got one rating and then LG has got second. Of course, the sales is another number, but just think about this thing. For example, if you talk about male and female, right? So if you want to give one to male and two to female, it doesn't mean that like female has got higher advantage, or you can say one to female and two to female, right? So there is no logical order, right? Wherein you can say one is other than or above than the other. The second kind of data we have is called ordinal data, which contains more information. It consists of distinct categories in which order is implied, which means by looking at the options, you will be able to understand that there is a certain order, there is a degree of superiorness in the data. For example, who is more educated? A person who's got just 10th or 12th, or a graduate or postgraduate, or a PhD guy? So if I'll say that PhD guy is the most educated one, then there is a degree of superiorness already allotted in the options. For example, what was the category, like what is the grade you got? So A has got better grade than like B as compared to C as compared to D, and so on and so forth. So there is a degree of superiorness which has been deployed in the data, and this is called as ordinal information. So if you say like, so nominal properties of nominal data are included already in ordinal, which means that what is grade you got, what rating you got. So you will get excellent, or you will get good, or you'll get fair, or you'll get poor. Any one of them will appear, only one of them will appear. They are mutually exclusive. You can have one and only one, but there is a order defined. Excellent is being the highest rating, good is the next to it, and then fair is the next lowest, next lower, and then the poor is the last lowest one, right? So this is order employed to it. Then we have interval ratio. Interval ratio means that there is a set of numerical measurement in which the distance between the number is of known and a constant size, which means that, for example, if I say when I go for a walk, I walk for 10 kilometers and somebody is walking for 11 kilometers. So if I walk 10 kilometers, I cannot walk 11. If I walk 11 kilometers, I might have included 10. But the point is that either I'll be saying 10 or 11. So I'll be picking a one value, which is one and only one value. Then 10 is lesser than 11, right? 10 is lesser than 11, so ordinal information is also included. And I will say I exactly know the difference between 10 and 11. There is an exact 1 kilometer distance. So that the difference between the options is of known and a constant size, right? The problem with this kind of data is sometimes, for example, if I say that at my place the temperature is say 5 degrees centigrade, and you will say that at my place the temperature is 6 degrees centigrade, so I know that the difference between the temperature is exactly 1 degree. I know there is a constant difference between the temperatures. Now this interval kind of data do not have often a true zero. For example, when I say that the person has got zero salary, it means that he's not getting any salary. However, for some of the cases where I say the temperature is zero, it doesn't mean that temperature does not exist. Very much like if I say that zero salary means that salary does not exist. If I say temperature is zero, it doesn't mean that the temperature does not exist. It doesn't mean that. So interval data has got fixed constant size difference between the numbers, and also that it doesn't have a they don't have the true zero value. Ratio data, which consists of numerical measurement where the distance between the number is of constant size. In addition, there is a non-arbitrary 0 point, which means that here the zero means zero, that the number is constant. For example, if I say the one guy is 6 feet, the other guy is 5, the other guy is 4, I know the person can be only either 4 feet, 5 feet, or 6 feet, or any number in between. So only one and only one value will appear. Ordinality has been included, wherein you know that 6 feet guy is taller than 5.5 feet guy. And then you also know that that how much is the difference between 5.5 feet and 6 feet. You know the difference between them, it's a constant difference. And but there is a 0 point, non-arbitrary 0 point, which means that if the height of the person is zero, it means that the person does not exist. Or any person or anything which has got something called as zero, it's called that thing does not exist. So it's a non-arbitrary 0 point. And so these are the four kind of data. So we have nominal data, ordinal data, interval data, and ratio data. I hope it makes sense to you, right? Now this is pretty interesting fact, right? So when you talk about qualitative or categorical data, so we call it as categorical data as well. So till now we've been talking about the qualitative, but you can call it as categorical data as well, because most of the time the data is being divided into categories. So category data represents the characteristic, therefore it can represent the things like gender, languages, um, right? This is one of the example, right? Like if I say that I speak Chinese, I speak Hindi, I speak English, or I speak Russian, for that matter. So I'll be choosing one language at a time, but you cannot rate like which language is best. Like you cannot have ordinality in that data, which means that you cannot assign 1 2 3 4, right? Often we pick up categorical data and change that data into some numerical measure. For example, I would say Chinese 1, then Hindi 2, then English 3, and then Russian 4. It doesn't mean that if English is coming on the third, it is superior or inferior to Hindi or Chinese for that matter, right? Or Russian is coming on the fourth, then it is inferior or superior to English somewhere, right? So we just wanted to convert these categorical numbers into some numerical placeholders. However, these numerical placeholder will also start acting like categorical data. You still cannot take average, mean, median, variance, standard deviation of this data, but you just using up placeholders, because computer play well with numbers, not with the text. So if I just tell my computer that I have got 1 2 3 4 data, my computer will be able to process my data faster, rather than I will say Chinese, Hindi, English, and Russian. So they don't understand the text. So we need to convert our categorical data into some kind of placeholders, where I would be calling them in some numbers like 1 2 3 4, something like that, right? However, there's one thing, 1 0 1 2 3 4, you cannot take average of it, so you cannot apply numerical measure. So even if you're converting into numerical measures, they will still act as qualitative data. Now what we are going to do is like next is that we're going to understand the basics of statistics from the scratch. So I want you to stay tuned with me so that I can talk about the statistics from the very basic, and I'll take you to the next level of analytics. I'll see you in the next video.